challenges. We ultimately had to map digitally, provide a 3D digital map of all the utilities that were in the area. We had to keep the plant operating, and it was similar to trying to do open heart surgery. You know, when you do open heart surgery, you got to keep the body still functioning. You got to have the blood flowing. Well, we had to have chilled water and hot water still flowing in our central terminal area, and while we were building something new and building all the cutovers as the new plant was ready to be commissioned. It was quite a logistical and coordination challenge to keep that operating. And so the replacement cup scope, we wanted to basically double the chilled water output. We were going to change the delta T. The delta T was the difference in temperature of water leaving the plant versus the return water, the temperature of the water when it was used and came back to the plant. We were going to close to double our hot water. We were going to generate about the same amount of electricity with our cogeneration system, but we were going to use that power internally. And we were going to take as much energy from the original natural gas that was used in the turbine to operate the plant and make it as efficient as possible. And one real big thing is we were going to substantially lower our emissions, which was a big issue for the Southern California Air Quality Management District. And we were going to have a new facilities management control system that was going to tie into the building automation systems that would be digital and would be much easier to manage. So the chilled water, we had 5 4,000-ton chillers that looked like that. Plus we had 2 steam-driven chillers. And so we're using the steam from the cogen process to operate our steam-driven chillers. Of course, we had pump rooms and to distribute the water, to push the water. We had cooling towers. We built cooling towers with 10 cells. Each cell was processing 6,200 gallons per minute of water. We built a thermal energy storage tank. This was something new for us. It's a huge tank, 1.5 million gallons. Very cold water on the top, return not quite as cold water on the bottom, and natural phenomena that will occur with water, a thermocline that keeps the two separated. Water enters and leaves in a laminar flow type of arrangement, so there's no turbulence within the tank, so it doesn't mix. And by doing this, during when energy is cheap, we can produce chilled water and fill the tank from the top, and it'll push that thermocline down. And when energy is expensive, we can withdraw the chilled water as opposed to using electricity to produce it. And the return water, the warm water, will fill in from the bottom and push the thermocline up. It's a way of storing chilled water. And it gave us a lot of flexibility in how we then operated the plant during peak operations. This is what that tank looks like. This is the diffuser at the top to allow water in. These were the cogeneration turbines. There were 2 of them. Each would put out 4.4 megawatts of power, fueled by natural gas, ultra low emissions. And this was a huge feature that we were looking to achieve. Cogeneration starts with natural gas, goes into the gas turbines, and produces electricity and heat exhaust. The electricity was used to fuel or to operate the central utility plant itself, or we send electricity back to the grid. The electricity would also operate our electric chillers, which produce chilled water that then goes to the buildings. The heat exhaust goes to the heat recovery steam generation, which produces steam, which then runs heat exchangers that produces hot water that goes into the terminals and operates the steam-driven chiller that produces cold water that goes to the terminals. And that's all used for the HVAC systems in the terminal buildings. This is the heat recovery system. The steam comes in here, or the exhaust comes in, the hot exhaust comes in here, and these work in concert with boilers and produce steam. This is the upgrade of the control room. Had a video wall. We were able to monitor everything that was going on in that plant, as well as everything that was going on in the terminals. This was a huge improvement that made operating the plant much easier. But one of the challenges that we had is we had operators that were used to operating an analog system. They were used to turning dials and turning valves to make the plant work. And converting them to the digital age proved to be one of the training challenges that we had when we commissioned the plant. And of course, then we had pump rooms into the terminal buildings, where the chilled and hot water was distributed and then pushed through the terminal buildings, and then from these rooms were returned back to the Symphony Filling plant. And that's what the final plant looked like. Thermal storage, the plant itself, the cooling towers. This was a $550 million project at LAX. So let's look at the current capital improvement program for the Los Angeles Airport at LAX. They're midway through the construction of what we're calling a midfield satellite concourse. And this is the north part of that concourse. There will be a future south part of this construction. It consists of 12 gates for aircraft. It will accommodate the new large aircraft, the Group 6 aircraft like an A380 or a 747-800. It will not have ticketing. Ticketing will occur in the international terminal, which is here. Access to this terminal comes from a tunnel that is actually underground. We'll have moving walkways. It'll have hold rooms, it'll have concessions, it'll allow passengers to board. Arriving passengers who are domestic, who are not international, will be able to go back through the tunnel and exit. International travelers will be cordoned off into what we call a sterile corridor, and they will have access and be processed through the customs facility that are in the Tom Bradley International Terminal. This is going to provide much needed contact gates. At LAX, we have what are called remote gates where passengers have to be bused to the aircraft and bused back to the terminal. And this will provide contact gates, which is a much higher level of service for the passengers, which is one of the objectives of the airport today. The other major part of their capital improvement program is the Landside Access Modernization Program. There are three major components to this. The first is a consolidated rental car facility. We have, over the last, as long as I was there, so probably the last 25 or 30 years, been slowly purchasing up this entire neighborhood. And we were down to, I think, when I retired in April, we were down to probably just a dozen properties that we had not yet acquired, that we were now going to condemnation to acquire. It was a voluntary acquisition, but this is where we're going to build the consolidated rental car facility. It will be able to accommodate, in terms of ready return, maintenance, or storage, 25,000 vehicles.
That's a question. That's a question. Do rental cars need to be parked so that every car can come out in, or can they give you a consolidated, really small?
Well, I don't can tell you how they're going to operate this facility, but the intent of the facility, they'll have storage for cars. They'll have a ready return area where, as you come into the facility, you'll be able to drop your car off and go back to a desk. Unless you're like a old person, you just flash your card and they take care of you. So go back to the desk and the paperwork is taken care of. And then they will have an area for each of the car rental companies where the cars are ready to pull out and go. Okay? And so currently at LAX, car rental is dispersed over probably 4 square miles. They're just dispersed everywhere. And one of the challenges that we have with that is that they need to have shuttles that pick up people throughout the terminals. And this facility will consolidate shuttles down to 0, because access to this facility is through one of the other features of the Landside Access Program, which is the automated people mover. which will take passengers all the way into the central terminal area here. Let's talk about the automated people mover. Not next, but it'll come. I have more slides on that. The other major feature is an intermodal transportation facility. This shows the west parking garage. There will be an east parking garage as well. And this is where, in the future, passengers will go to park long term. This is also where taxis and Uber and limousines, the Disney bus, the Van Nuys shuttle, MTA will all drop off and pick up there, as opposed to taking those larger vehicles into the central terminal area where there is great congestion. And then, as I said, the people mover is the other feature. Now, the people mover will pick up and drop off at the Conrack. It will have a connection to light rail, which is in construction right now. It'll have a station here at the Intermodal Transportation Facility, and then it will have several stations within the central terminal area. Here's some renderings of what that people mover will look like. Here's that thermal storage tank in the central utility plant. Here's the iconic theme building. But this is quite the facility. We've released the contract. It's a $2 billion design, build, finance, own, operate, and maintain contract. It's a new procurement process that we're utilizing for this particular type of a project. It's not just design build. It's not design build, but it's got the finance component, the operate component, and the maintenance component. So it's a different way of operating. 2.2 miles. 7 stations. It'll take 10 minutes from one end to the other. Free to airport users. But this will alleviate the huge congestion. If you've ever flown through LAX, it's tough to get in and it's tough to get out because of the traffic congestion. Of course, the construction of this will only exacerbate it. Yes?
You say who wanted this to happen or not?
I am not sure who wanted it because it was awarded after they retired. So let's move the Ontario International Airport. This is where I'm currently doing a lot of work. And prior to the sale of the airport back to the Inland Empire, I was part of and oversaw a lot of work that occurred at Ontario. It is much smaller in terms of operations than LAX, only 5 million passengers in 2018. It was previously in the top 50 in the nation. During the economic downturns of 2001, when we had 9/11, and then in 2007, 2008, nearly half of the passengers that we would normally see in Ontario went elsewhere, and they went elsewhere to LAX. The industry consolidated around larger hub airports. And so Ontario is in a recovery mode from that. They have still not recovered all their passengers. Ontario is well suited for cargo. They processed 750 million tons of cargo. At the airport, it's bounded on the south by railroad, on the north by railroad, on the north by a freeway, I-10, on the south by a freeway, the 60 freeway, and here on the east by I-15. It has great commerce access, and so, and then if you were to take this aerial and blow it out a little bit, you would see that the region surrounding the airport is warehouses. It's just a huge warehousing area. And so cargo is going to be one of the big areas of growth at Ontario. In fact, this last year, it was the fastest growing airport in terms of cargo in the nation. Had 88,000 operations. Still, $5.4 billion economic impact to the region, and 7,700 jobs directly attributed to the airport. And as I said earlier, in 2016 was reacquired by the City of Ontario, counties of San Bernardino and Riverside. So they have a new board, and they have a new outlook on how they want to operate, and they have a vision that I think is quite impressive. So their vision includes plans for landside where they're going to be, in the short term, just doing improvement in the parking, but long term, they're going to have a parking structure. They're going to have to relocate and expand their car rental facility. And they're going to have to do airport access improvements from from all sides in terms of access off the freeways, off the surface streets. And there are plans to also make a connection to light rail that services that part of the Ontario and the San Bernardino County. Terminals. The existing terminals are now 20 years old, but they're lightly used and they're still in really good condition. But they were designed in the 1980s, built in the 1990s, and they really represent an antiquated approach to how airline terminals should be designed and operate. And so, long term, we are looking to replace those terminals and provide more contact dates for aircraft to be serviced at the terminals. As I said, cargo is a big opportunity area for us, and so you can see that land is being allocated for expansion to cargo. We have the boot property because it somewhat resembles an ugly boot, and that's just clear space for us right now without any plan for development. And so there's one of the things that I am doing and working with the consultant Dean Fisher in defining how that property might be used in the future. And then on the air side, we have a pretty good airfield. But we're going to be adding taxiways to get access to the cargo areas. We have one of our runways is 40 years old. And so we're currently looking at how that runway might need to be rehabilitated or possibly replaced, because 40-year-old concrete pavement that had aircraft operating it's wearing out. So let's talk about pavement a little bit. I mentioned earlier that pavement is one of the most critical assets that an airport will have. This was a pavement condition index map of Ontario that was prepared around 2010. And dark green, really good pavement. The lighter green, satisfactory. And then as it gets into your reds, poor pavement and pavement that has failed would be gray. You can see that the runway 26 right here is in super excellent condition. That's because it was rebuilt in 2005 and is an amazingly good condition. Runway 26 left is the one that is 40 years old. The yellow around the edges are the shoulders of the runway, and they're asphalt and they're just falling apart. And so those are going to have to be replaced. The main operating surface of the runway is down the center line, and you can see that that was in 2010 in satisfactory condition, but was wearing. And then you can also see other areas where we have some pavement issues. This is Taxiway Sierra, where we are programming a project to rehabilitate that. And one thing that didn't show up here, but we had to actually have some replacement. This area here, this connection to Taxiway Sierra and Whiskey, actually started crumbling on us, and so there was a recent project to replace that. The FAA requires every airport to have an airport pavement management system where you will go through an exercise of visually inspecting and then non-destructive testing, some destructive testing, which would include cores, to define what the pavement index is, the quality and condition of your pavement. And this information is then used to develop what we call an ACIP, an Airport Capital Improvement Program, which is submitted to the Federal Aviation Administration, where we would then apply for grants to manage, replace, rehabilitate, provide new pavement. And the ACIP grants, or the AIP grants, are almost exclusively for pavement issues that come from the FAA. So the pavement, this is the typical pavement that we put in for when we did the runway 26 right replacement. The runway itself is 150 feet wide. The pavement, Portland cement concrete, is 17 inches thick. It rests upon a cement-treated base, which cement-treated base is they take cement, mix it in with the soil, water it down, and they compact the living daylights out of it. It becomes a very hard, dense surface on which the runway rests. Then it has a subgrade that's compacted to 100%, and then another subgrade that is 18 inches thick is compacted to 95%. Now, the soils that are on Ontario are amazing. It's really good soil to work on and construct on. The soils at LAX are much different. If I were to show you a typical section of an LAX runway, we recently, in the last 10 years, replaced runway 25 left at LAX, and that runway was 21 inches thick, and it rested upon 2 feet of Econocrete. Econocrete is about a 3,000 psi type of low-grade concrete, which then rested upon a compacted base, and so the structural section at LAX is much larger, because LAX has rotten soil. They have lots of sand, they have lots of clay that when you hit the clay, you've got to get it all out and then replace it with a suitable fill material. So runways really critically important. Yes?
You have to make the sections even stronger where the plane's land.
No. The runway itself would have the same strength in terms of PSI. And by the way, this concrete, very hard concrete, we were achieving 5,000 PSI in 5 days. And so it's really hard. Now, one of the reasons that we would be able to achieve that, you can see this is the construction of that runway. This is the cement treated base material here. There are duct banks and conduit that's put in underneath the runway for the cans that hold the runway lighting and the taxiway lighting. You can also see doweling that is in here. When you get out there and construct the runway, you'll construct it in a 20-foot wide section. And the runway is 2 miles long, and so in a day they might put down 2,000 feet of runway. The next way they'll put another 2,000 feet in a 20-foot wide section. What will happen as that section is put down, and I'm trying to see if you can see, but you can see areas where they have saw cut across the fresh concrete, and they will create basically 20 by 20 panels in the concrete. And over here you can see where they have doweling that actually comes laterally across the runway. And those dowels would be underneath where those saw cuts are. So each panel is doweled into the panel next to it, both longitudinally and laterally. And so the runway itself is it's all doweled together, and that's to create a great deal of stability in the concrete. Here's the paving operation, and again you can see the lateral doweling that would be in place as the paving machine would come along, and then that's where you get saw cut on top. Then you can see all the doweling that's on the side. Now this runway, when it was placed, had no forms, okay? And so it had to be extremely stiff, had virtually no slump. And because of that, and then the concrete mix design that they had, we were able to achieve 5,000 PSI at 7 days. And then you can see here, this is where the asphalt shoulders are. For the shoulders, you would put in asphalt. So you have a 150-foot wide runway. You would have shoulders that are about 75 feet that would be asphalt. All right. This is a project that is just begun out of Ontario. I mentioned that cargo is a big opportunity for development there. This is Federal Express's new facility that they have proposed. And they have actually started construction. It'll accommodate 8 new apron areas for large aircraft. They'll also have some regional aircraft that will be there. Their intent over time is to also acquire this additional 38 acres and expand their facility. And this will replace the FedEx cargo facility that is in LAX, and this will become their Southern California hub. And so they are looking to have some substantial expansion in cargo at Ontario. This is probably the most game-changing project at Ontario right now. And we are in the process of awarding bids. We received bids. This is a design-build project, and it is the replacement for the Federal Inspection Service facility at Ontario. The existing facility shown here has been in place since the late 80s. And it provides about as low a service as you could possibly have for an international terminal. It only accepts arrivals, which means there's no ticketing, there's no departures at this terminal. It only accepts arrivals. There are no boarding bridges. There's no way to disembark an aircraft except on steps or ramps and you walk to the terminal. And so it needs to be replaced, and it'll be replaced with this facility. It'll have 4 contact gates. Here's an artist rendering of it. It'll connect to our terminal too, and so there will be ticketing, hold rooms, boarding. It'll have sterile corridors to allow for arriving passengers to go into customs. This is an artist rendering of the baggage claim. It has high ceiling, which makes it a very open, airy type of feel as you look come into customs. It'll have a premium lounge, and because of the weather in Southern California, where it's not freezing outside, you can have an open air premium lounge as well as an inside area. This is what the customs area will look like. This is the baggage claim area that we already saw. It'll have a meter greeter area. It has customs processing. This is the hold room, and then this is where the premium lounge is. This is a game changer because we really can't process international flights efficiently until we have this. And there are airlines waiting for it to operate, to come into operation where they can come to Ontario. These are just slides of development, and I apologize, I didn't give enough time. If you have any questions,